Okay, we're going to continue our series on calculations for the National Electric Code. We're going to do some box fill calculations. We're going to start with our 4 gauge or larger, and then we're going to go to our smaller sizes. But for now, we're doing 4 gauge or larger. Now you can reference this at section 314.28, paragraph A1 if you like. We're talking, first of all, straight pulls. So it's the straight pulls of 4 gauge wire or larger. Now, if it's a straight pull, and you can see what we're talking about here, let me get my pointer out. Okay, we're talking about going straight across. That's a straight pull, right? Okay, so if we're doing this and we want to know the distance here, it's really, really simple. The distance, the length of the box, it shall not be less than 8 times the trade size of the largest conduit. So we just go over here and we take the 2 and we multiply it times 8. It is a very simple calculation. And then this number is going to be 16. That is the simplest. That's just so simple. It's just, you would probably remember that instead of having to go back and find it in the book, box fill and then what have you. Probably remember that. The next one is a little bit more complicated. So what we're going to be talking about here is an angle pull or a U-pull. Now what I'm really showing here is a U-pull. So we're going to go in and then we're going to come out and then we're going to go this way. Or it could be a splice as well. You got all these these wires, these conduits coming in with wires, obviously, and you're going to tie them all together in this box. This works for a U-pull, all right, or a splice or an angle pull. So if you were going to come in this way and go out this way, it works. It's the same calculation. Okay, so I'm going to read this to you and then I'll explain it. I know it's a lot of words here. The measurement to the opposite side of the box, all right, from the entering conduit to the far side of the box shall be 6 times the trade size of the largest conduit entering the box on that side, plus the sum of the trade sizes of the remaining conduits entering that side of the box. So it's 6 times the largest and then just add the others. So if you want to hit the pause button and see if you can do that, see if you can get the right answer, then you can hit that and come on back and see how you did. So it's 2 times 6, 6 times the largest, plus 2, plus 1, and we're going to get 15. So the distance here from here to here has to be 15 inches. All right, this is really, really simple stuff, and you should probably be able to remember that one and just answer that one right off the top of your head once you get that question. You might get a 3 and a 3 on this. If you had a 2 3-inch conduits entering the side of the box, if this was a 3 and that was a 3 and that one did not exist, what would be that distance? Hit the pause button, see if you can figure that out and come back. Yeah, 3 times 6 is 18, plus 3 is 21. So that would be 21 inches from here. Okay, here we go. Those are too simple. Those are the box fill calculations for 4 gauge and larger are really pretty simple. All right, so now we're going to go to the other one. We're going to go to the smaller box fill calculations. So these are box fill calculations for 6 gauge and smaller. All right, so there's a system that is used. So each conductor or other item or device that is in the box is given a value. Okay, it could be a 1 or a 2. The total determines the size of the box. So a conductor that originates outside the box and terminates inside the box, which that's of course very common, that gets a 1. A conductor that just passes straight through the box, that gets a 1. Okay. Now a conductor longer than about 12 inches that is inside the box gets a 2. Okay. Now I say about 12 inches because if you go back and look at some previous articles or paragraphs that are referenced, they talk about you're supposed to have a 6-inch tail from where the conductor comes out of the conduit into the box and so on and so forth. But the bottom line, if it comes in, makes a loop, it's longer than 12 inches. you're going to assign that a value of 2. I really don't think you're going to see it on the exam, though. If you got a clamp inside the box, it's going to be a 1. A stud or a hickey is going to be a 1. All right, and then a device or equipment like an outlet or a switch is going to be a 2. All right, so and then you're going to add all those together, and then you're going to take that number and go to a table. All right, but I got to tell you, I don't know that you're going to see the device or the stud or the hickey or the clamp. More than likely, you're going to be focusing on conductors and conductor sizes. Okay, that's really where you're probably going to be asked questions, but we'll talk about all of it just in case. So here we go. I want you to find this table 314.16a, and this is one of the tables we're going to use when we're doing these calculations, especially when we're using. Actually, this is same size or different size conductors. We're going to start with same size conductors because that's going to be the simplest one to talk about, and then we'll build onto that. So the question is, what is the smallest box needed to accommodate 10 14 gauge conductors? All right. Here are my choices, and I want you to hit the pause button, see if you can find it, and then hit the play button when you're ready. We think you have the answer and see what you got. Okay, so we're going to give you the answer now. So you should have come over here to 14. 14 is our conductor size. All right. Down here, this is how many conductors, the maximum number of conductors. So it's referenced by conductor size. We're talking 14 gauge. So we come to 14. We have 10 conductors. So we have to come down to where it says 10. All right. So we see 10 here, and we see that we can use a 4 by 2 1/8 round or octagonal, and that's 21.5 cubic inches. But here's the little tricky part. You can also get 10 of these conductors, these number 14s, in this box, which is a 4 by 1.5 square. Okay, that's what it says, 4 by 1.5 square. That's kind of small for me. I got to make sure I can find that. 4 by 1.5 square. All right, so what you've got here is this one is 21. This one is 21.5. So in actuality, it's the 4 by 1.5 square that is the correct answer. Did you get that one? So the actual answer is D, which is 4 by 1.5 square. Did I get you on that one? Yeah, you got to pay attention. This particular question, I want you to remember. Yes, okay. Be very, very careful with that particular one. It's not such a hard question because it's all the same size. You really didn't have to do any calculations, but you got to pay attention to that particular one. So, let's see. It's a little tricky. Okay, so we'll move along. That may be all you need to do on the exam, but I don't want to shortchange you here, so I want to take you a little bit further just in case you do see more. All right, so now what is the smallest box that can be used for? Now we're going to say 8 12 gauge, 6 10 gauge. Now we've got a hickey and we've got a device. So remember from before, we're going to assign a hickey and we're going to assign a device a particular number, all right? And then we're going to actually have to look at this table because what's going on now is we can't just come up here and look at and use the table and come down and go boom and come across and figure out like we did this one. Well, you remember the 14 gauge? We came down, we looked at 10, we came across, they were all the same size, so we could use these up here. Well, we can't do that now because we have 12 gauge, we have 10 gauge, we have two different size conductors. So now we have to do some math. Okay, so what do? We see how big the 12 gauge is. The 12 gauge is 2¼ cubic inches. That's what we have to account. 2¼ cubic inches is the amount that we have to account and use for our 12 gauge conductor. Our 10 gauge is going to be 2½. Okay, so we've got 2. Now we have the Hickey and we have the device. What do we do about the Hickey and the device? Well, let me show you. All right, so now this is the exact same slide I showed you earlier. I'm just adding some information here. When you have clamps, Hickeys, studs, devices, all these types of things, they're always going to be based on the largest conductor. All right, so you've got to base the amount that you're going to use for the fill equation on the largest conductor. So our question was, what is the smallest box that can be used for 8 12s, 6 10s, and 1 Hickey and 1 device? When we do our Hickey and our device, we're going to have to account for a number 10 gauge, all right, fill, okay, cubic inches. So, and also remember on the device or equipment, the switch or the outlet, that counts as 2. All right, and you think about it, that's a pretty big little thing that fills in a lot of the box. When you try to jam that outlet in there, you know, it's going to take up a lot of room, right? So think about that. That's a number 2. That's 2. That's based on 2. All right, so let's go back. So we have 4 number 12s at 2¼ and that's going to be 9. We have 4, that's going to be 6. That's going to be 6 number 10s at 2½. So 6 number 10s at 2½ is 15, right? And then we're going to go and we have 1 Hickey, which we're going to use 2½. We have a device which counts for 2 at 2½. That's 5, and we're going to add them all together. We're going to get 15 plus 9 plus 15 plus 2½ plus 5, and we're going to get 31.5. 31.5, we go to our table, and we want to find out where can we use a 31.5. What is our box? We can't use, we go to the square, they're cubic inches. We can't use this one. Can't use a 42. That looks like it's going to be the only one on the table that we can use. Nothing else is bigger than 31.5. So we got to go to the 42. And we have to use, where's our 42? 4 11/16 by 2 1/8. Wow. Okay, so that's how you do that. Very interesting, very interesting. We'll have some practice questions for you to do so you can practice on your own on that. Okay, so here we go. Now here's a conclusion. Okay, you've got to know the larger boxes, the larger gauge wire. The 4 gauge and larger, you better know those calcs. You're going to get one. Understand how to read the box fill table at a minimum for the 6 gauge and less, okay, especially when using the same size conductors. And I don't know that you're going to get a calculation on the 6 gauge and smaller, but know how to do that as a bonus. All right, this has been Jack Sheffield, Jack the Exam Guy. Just want to tell you to be doing the right thing out there, be doing the right thing with your life. You know, remember there's other people that are not as talented as you, they're not as smart as you, they're not as lucky as you to be getting their contractor's license, their electrical license, and they need a little bit of help too. So always keep in mind, maybe pick a charity, you know, Tunnels to Towers or something like that. I always like to give a little bit of money to charity. I'm doing well, I'm working with you. Find people who are just really, you know, movers and shakers and doing the right thing. It's great to be working with you guys and girls. But we also all need to give back a little bit. So think about that. This has been Jack Sheffield, Jack the Exam Guy. I really appreciate your business. Appreciate working with you. Always call me if you want to. 904-755-4111. Just say hi. All right. See you soon. Good luck on the exam.